Greetings, my name is Alex. I'm from the Babeș-Bolyai University of Cluj-Napoca, Romania, and we'll be briefly discussing our recent paper entitled Optimal Stereo Camera Calibration via Genetic Algorithms. The question often arises whether we can instruct a computer to measure real-world 3D distances, and the answer is yes, out of which the most cost-effective solution would be to equip it with a stereo camera system. This has some limitations because all camera lenses exhibit some form of distortion, but can be alleviated via a process known as camera calibration. Camera calibration boils down to estimating the camera intrinsic and extrinsic parameters, out of which we mention focal length, distortion image center, and real-world position and orientation. So there are a wide variety of existing calibration algorithms. We use the one provided by the OpenCV framework. Basically, you take photos of a chessboard pattern under different poses. There is no upper limit to the number of acquisitions, but more acquisitions does not necessarily imply a better calibration. So now supposedly we already have our acquisitions. Should we consider all possible subsets of stereo image pairs in order to perform the calibration, because the solution space in this manner is very hard to explore. It is basically huge. So which is the subset that provides the best calibration, and what does best calibration mean? Because the root mean square error or average reprojection error, as it is returned by the calibration routine, does not necessarily imply a better 3D measurement. And of course, after performing the measurement, you are not able to determine which of the pairs out of your total number of acquisitions are detrimental to the calibration process. So the solution we came up with is a genetic algorithm that identifies the optimal subset of calibration images. Basic genetic algorithm structure: chromosome encoding is binary encoding, bit flip mutation, single cut point crossover operator, and we added on top of these some sugar flavors, cataclysm and Garden of Eden, in order to help the algorithm escape local minima. The results, the experimental results are very promising. For stereo calibration compared against the BoofCV framework, we obtain an improvement by a factor of 10. And the plots also show that the algorithm is performing meaningful computations. The errors are decreasing as iterations progress. And for mono calibration versus Peng's proposed method in 2019, we obtain an improvement by a factor of 2. So yes, we do provide improvement over existing techniques. We do provide a unified and fully automatic pipeline for doing so, and the execution time is minute and needs to be done only once per stereo system or mono system. Of course, for more technical and in-depth details, we kindly ask you to refer to our paper. Thank you.